Welcome to question 7 of the 2018 Mathematical Methods Exam 1 for the Southern Hemisphere. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. So for question 7 we have let P be the point on the straight line y equals 2x subtract 4 such that the length OP, which is a line segment from the origin to the point P, is a minimum. For part A we want to find the coordinates of the point P. So to start off with we're going to do a sketch of what's involved in this question. So the straight line with the rule y equals 2x subtract 4 is this straight line here, and it has coordinates of 2, 0 for the x-intercept and 0, -4 for the y-intercept. And now the origin is here with coordinates 0, 0. And there is some point P which exists on this line here such that the distance of OP is a minimum. And because P lies on the line y equals 2x subtract 4, we know that P has coordinates x, y, where its y value is simply 2x subtract 4 as well. And now for this question, the first method of answering it, which we will show, is that the perpendicular distance is the shortest possible distance. So that means we're looking for a line that is perpendicular to the rule y equals 2x subtract 4 and it passes through the origin. So therefore we know that the line that we're interested in is y equals -x on 2. And that's because the gradient of the line y equals 2x minus 4 is 2. And we know that perpendicular gradients multiply to give -1, so we need a gradient of -1/2, and going through the origin means the plus c value is simply 0. From here we just solve those two equations equal to each other. So we have 2x subtract 4 is going to equal the line with the rule minus x on 2. And now if we add x on 2 to both sides, we get 5x over 2, or 2.5x, and then adding 4 will give 5x over 2 is equal to 4, so therefore we find x is equal to 8 over 5 when we solve that equation. And now that we have x, we need to find y, and we know y is equal to -1/2 times x, where x is 8 on 5, so that gives y is -4 on 5. So overall, the coordinates of the point P are x is 8 on 5 and y is -4 on 5. So that is the answer to part A of this question. From the examiner's report we can see that 30% of students got this right, and we'll go through the examination advice in more detail in a moment, but this is the summary of method 1 that the examiner's report presented to students. And now we're just going to do part A again using a slightly different method, and that is using the distance formula. So we know that the distance between 2 points can be expressed as x2 subtract x1 squared plus y2 subtract y1 squared. So for this question, our distance equation, which involves the variable x, is going to equal the square root of, and we have x subtract 0 squared is the difference between the x value and the origin, plus, and the y value to the origin would be 2x subtract 4 minus 0 squared. So therefore the expression for the distance in terms of x can be expressed as, and this first bracket squared gives x squared, and then 2x subtract 4 squared gives positive 4x squared, and then we're going to have minus 16x and plus 16. And now the distance expression in terms of x can be simplified slightly further. So x squared plus 4x squared gives 5x squared minus 16x plus 16. And now to answer this question, we need to minimize the value of the distance expression. And that could be done by calculating the derivative and setting it equal to 0, or we can just inspect that we want a minimum value for whatever's underneath the square root sign. So therefore we want to calculate the derivative d dx of 5 x squared minus 16x plus 16 is equal to 0. So therefore we want 10x subtract 16 to equal 0, which gives x is equal to 8 on 5, like we found previously. And just to wrap this up, we would find that y is equal to minus 4 on 5 by substituting that back into the rule y equals 2x subtract 4, which gives the point P being the same as what we found using method 1, as being 8 on 5, comma, negative 4 on 5. So that would be the answer to part A of this question, using a slightly different method which involved the distance formula. So the examiner's report also showed method 2, which used the distance formula, and the examiner's report goes on to state that students who solved the problem using method 1 were generally more successful. Students who tackled the question by finding an expression for OP in terms of x and then setting the derivative equal to 0 often had difficulty finding the derivative correctly, which ended up with an incorrect x value. However, most students did go on to calculate the y coordinate, and some students opted for a solution by working with similar triangles. A common incorrect response for P was 2, 0, which was the point of intersection with the line y equals 2x minus 4 and the x-axis, while others incorrectly assumed that the point P was midway between the line segment formed by y equals 2x subtract 4 and its axial intercepts. For part B, we want to find the distance OP, and we need to express our answer in the form a square root of b over b, where a and b are positive integers. So given that we've already found the coordinates of P, we know that P had coordinates that were 8 on 5, comma, negative 4 on 5. And that means that there's now a right angled triangle here, which I'm drawing in purple, which could be used to find the distance between O and P. So drawing that triangle out a little bit larger, we have this is the triangle here. This is a right angle. This was the origin O, and this was the point P. So we know that the x value of P was 8 on 5, which makes this length 8 on 5, and that the y value is negative 4 on 5, so just for the length this is 4 on 5. So we know that the distance OP squared is going to equal a squared plus b squared using Pythagoras, which is 8 on 5 squared plus 4 on 5 squared. So therefore OP squared is going to equal 64 on 25 plus 16 on 25, which is equal to 80 on 25. Therefore the length OP is equal to plus or minus the square root of 80 over 25. However, we know that OP is a length, so it must be positive. So it's going to be positive the square root of 80 over 5, and we're now getting it close to the form we need it in. And the square root of 80 can be simplified because 16 is a square number that goes into there, so we can write it as the square root of 16 times the square root of 5 divided by 5, which simplifies to 4 square root 5 over 5. So that is the answer to part B of this question. From the examiner's report, we can see that 45% of students got no marks for this question, and 27% of students got all 2 marks for this question. Overall, it was attempted well, even if it wasn't successfully done by all students. The issues that some students had was misquoting the distance formula or making arithmetic errors in their calculations.